Try to picture Jupiter, the king of our solar system. A gas planet so massive it could swallow 1,300 Earths. Its storms rage on for centuries. Its gravity holds sway over 95 moons. Now imagine something 13 times more massive, compressed into the same space. So dense that if you're standing on the surface, you'll be crushed immediately. So hot that lead would boil in its atmosphere. So huge that it's only one atom away from sustaining nuclear fusion and turning into a star. This is not science fiction. This is reality. And scientists label it as TOI 4603b, the heaviest planet ever discovered. A planet that cannot exist. A space cannonball that goes against everything we know about planetary formation. And it's scary. Let us learn about Jupiter before we face this giant. Jupiter is 318 times heavier than Earth. Its Great Red Spot Storm is 3 times the size of our entire planet. You'd weigh about 2.5 times your Earth weight if you could stand on Jupiter's cloud tops. That's heavy. Its heaviness is no accident. It's on the edge of what physics allows us to have a planet. Get too heavy, and things change. Things fundamental. The division is about 13 Jupiter masses. Cross that, and you start deuterium fusion. The body is burning a special type of hydrogen in its heart. Temperatures soar to over 1,000,000 degrees. It's no longer a planet by this time. It's a brown dwarf, a star that failed. Too small to burn regular hydrogen like our Sun, but too big to be a planet. Visualize it as a cosmic razor's edge. Less than 13 Jupiter masses. Planet. More than that. Failed star. TOI 4603b sits on that razor's edge. December 2023. NASA's Transiting Exoplanet Survey satellite picks up a signal from a distant star. Something massive is blocking its light. Something enormous. Follow-up observations confirm it. A planet. Mass, 12.89 times Jupiter. Barely below the brown dwarf threshold. This is where it gets weird. Although it is 13 times more massive than Jupiter, TOI 4603b is only 4% larger in diameter. Same diameter, 13 times heavier. Do the math, which means it's incredibly dense. About 14 grams per cubic centimeter, nearly 2.5 times Earth's density. Except this is not a rocky planet. It's a gas giant, made mostly of hydrogen and helium. How do you pack that much gas into a package that small? Gravity. Compression. Unmerciful gravity crushes every atom to its limit. The surface gravity on TOI 4603b is roughly 12 times that of Jupiter. Jupiter already has us wobbling at 2.5 g. This planet? Over 30 grams. If you weighed 150 pounds on Earth, you'd weigh over 4,500 pounds there. Your bones would fracture. Your lungs would burst. You'd be crushed into the ground before you had time to scream. And that's with gravity. TOI 4603b orbits a star called HD 245134. It's located in the constellation Taurus, about 730 light-years from Earth. Its host star is a subgiant, bigger and brighter than our Sun, roughly 1.75 times more massive, metal-rich, burning the latter stages of its life. The planet orbits the star in 7.25 days. That's 7 days. Mercury orbits our Sun in 88 days. Mars orbits in 687 days. Earth orbits in 365 days. TOI 4603b orbits in a little over 1 week. It's 0.0888 astronomical units from its star. That's approximately 13 million kilometers. Mercury is 58 million kilometers away. It's 4 times nearer than that. The orbit isn't even a circle, though. It's elliptical, eccentricity of 0.325. The planet zooms in on its star, then zooms back out again, and again, and again. A pendulum of the universe. Astronomers suspect that another object is exerting a gravitational pull on it. Maybe a brown dwarf companion is lurking deeper out. Gravitational forces are warping TOI 4603b into this wild orbit, slowly drawing it in towards its star. Tidal forces will ultimately circularize the orbit, or the planet will spiral inward and be annihilated. Either way, TOI 4603b is the victim of fate. Let's talk about what it's really like in this world. Temperature, 1,404 degrees Celsius. That's 2,559 Fahrenheit. Hot enough to melt gold. Vaporize lead. Vaporize rocks. The atmosphere is under extreme pressure. Hydrogen gas compressed so much that it might be going into a metallic state. Electrons are pulled from atoms, flowing like liquid metal. Lightning storms cut through the atmosphere. Winds are screaming at thousands of kilometers per hour. The entire world is a boiling vortex of compressed gas and radiation. And don't forget that this object is barely a planet. It's at 12.89 Jupiter masses. The deuterium fusion threshold is 13. It's possible that TOI 4603b is already burning deuterium in its core, a small nuclear forge burning away. If that's the case, it's no longer actually a planet. It's a brown dwarf posing as a planet. The line is that thin. Scientists are not quite sure where to place it. 13 Jupiter masses, some of them claim. Others, it depends upon the composition. Metallicity. How many heavy elements and helium? TOI 4603b occupies that in-between region. Edge of 2 phases of matter. Edge of the planet and the star. It is the strict planetary mass upper limit. Push any further, and you are into something very different. That's what makes it so unsettling. It's a phenomenon that resists our definitions, makes us ask ourselves, what even is a planet? There are fewer than 5 known objects in this mass range. Planets more massive than 10 Jupiter masses are rare. More than 12, almost unheard of. Finding TOI 4603b gives scientists a peek into the fringes of planetary science, an area where formation theories break down. How did something like this form? Gas giants usually take shape far from their stars, where it's cold enough for ice and gas to cling together. They build a rocky core first, then pull in hydrogen and helium through gravity. But TOI 4603b couldn't have formed where it is now. It's far too close, far too hot. It must have formed out further and migrated inward, either through encounters with a protoplanetary disk or gravitational ejection from a different star or planet. Its eccentric orbit proves it didn't form peacefully. Something massive must have disturbed it, tossing it into a stretched, chaotic path until tidal forces slowly drew it inward. Most planets don't survive that trip. They either get flung out of their systems or burn up in their stars. TOI 4603b made it, just barely. Studying it helps astronomers understand how massive planets move, collide, and reshape their systems over time. It also challenges the line between planets and brown dwarfs. If something forms like a planet but has the mass of a star, what is it really? TOI 4603b sits right on that boundary. Half planet, half failed star. A perfect example of how nature refuses to fit our definitions. Now this is the most persuasive part. TOI 4603b could have been a star, if only it were a little more massive. If gravity had accreted just one Jupiter mass's worth of stuff during its formation, it would have exhausted deuterium fusion entirely. Then continued to accrete. Then eventually hits 80 Jupiter masses and ignites hydrogen fusion. It would have been a red dwarf star, burning for trillions of years. Instead, it's a planet, caught in the limbo. Always massive, never actually a star. There's a fine line in the universe between creation and incineration, between a world and a sun, between a planet and something that could have lit up the darkness for thousands of centuries. TOI 4603b paints that line, in the middle of the day. It reminds us that planets are not small stars. There are other types of objects, and between them, there is a gray area, a cosmic twilight where things exist in a state that doesn't fit our definition. Perhaps that's the real horror, not the crushing gravity or the fiery heat, not even the possibility of nuclear fusion in its core. It's the realization that the universe doesn't care about our definitions, creates things we can't help but define, coercing us into a total relearning of everything we once knew. TOI 4603b is drifting out in space somewhere, orbits its star in 7-day cycles, squeezing itself into two under its own weight, dangling on the edge of combustion, a cosmic fluke, a planetary extreme, a reminder that even on the verge of impossibility, the universe has a way of surprising us. And if one planet can exist on the edge of impossibility, what else remains to be discovered? Want to see more cosmic extremes? Subscribe and press the bell. First, we're venturing into the coldest planets. Next, the fastest rotating stars. Then, supermassive black holes that shouldn't even be here. Leave a comment. What is the most extreme object in the universe, do you think? Let's find out together. The universe has monsters. We've just barely started finding them.